to the first letter today and write it down. Don't say you will memorize it. Write it down on a piece of paper. Is the letter P. That's the first letter for today. And once you call back the letter P, I know you reached the class at least on time. So that's the first letter. Letter P, as in pumpkin. All right, so let's move to the first slide today. Last week, we were talking a lot about mosquitoes and how they can spread diseases. And we also spoke a lot about HIV and AIDS. So our starting point, since we were talking about vectors not too long ago, in case you can't remember, a vector, whenever they say a vector in biology, right? Whenever they say a vector in biology, most of the times they're talking about something that can spread a disease. Mosquitoes obviously are what? Vectors, because mosquitoes can spread disease to you. Other examples of vectors are like, well, roaches, it have rats, or all those things are vectors. But anyway, I want to focus on how we could actually control vectors. And the example I'm going to use is a mosquito, since that's the most popular one. Well, on the syllabus, there are about 5 different ways we can control vectors. The most obvious one, and I know I don't have it in order, but I just watch the little tick here. The most obvious one is chemical control. And I think everyone is real familiar with this one. Well, whenever there's mosquitoes around, or even flies, don't you run for that bug spray and you spray them? And of course, that kills the mosquito or sometimes the flies or the cockroaches or whatnot, right? So we can actually use chemicals because the bug spray is a special chemical that kills the mosquito. So here I have an example of a chemical method of controlling vectors. Bug spray. For rats, we could use what? Rat poison, right? Rat poison is what? A chemical. All right, so what's another way we can actually control vectors? Chemical is one way. The next one that's easy to, how you say it? That's easy to imagine is the mechanical method. A mechanical method is when you use force, physical force, to kill a vector. Mosquitoes or flies, and you can use a fly swatter, or rats, and you can use what's called a rat trap, the one that has a spring on it, and it actually crushes the rat. You call those mechanical methods. And how much of you all know what this is? Let's call it a bug zapper. It uses electricity, like the flies and the mosquitoes fly into the cage, and the cage is electrified, and it zaps them. That's also another what? Method, a mechanical method. So those are 2 popular methods, right? The rest, notice there are 5 on the screen: environmental, chemical, mechanical, gene manipulation, and biological. Those are already less common, so I wanted to spend a few seconds introducing them. I think everyone here is very familiar that water, you shouldn't have pools of water or containers of water around your house. Why? Because especially mosquitoes can lay eggs. And how much people have a pond by their house? Like the back of the house, they may have a pond, like a natural pond. Let's use that example. A natural pond is at the back of your house, right? So some people are saying, yeah, they have a pond. Now that's a pond. It could be good. I mean, fish could grow in the pond and whatnot, but a pond can also be a breeding ground for mosquitoes. So what some people do, they drain the pond. That, in other words, you change the environment. You create a channel and all the water drains out of the pond. Isn't that a nice way of controlling mosquitoes? You call that an environmental method because you're physically altering what? The environment to get rid of the mosquitoes. Also, let's say you know the rats are living in a piece of land. So what you do, you grade down the whole piece of land. You remove all the big grass and topsoil and thing. So now the rats don't have a place to live. They don't have the bush to live in anymore. So you physically change the environment. Right now, there are obviously drawbacks, right? If you remove the pond, you might get rid of the mosquitoes, but you might kill all the fish. So you have to make a choice whether that's the right choice for you. The other one, right, is biological control. How much of you all here, and it's only recently I discovered this, right? How much of you all just buy Coxet to get rid of the mosquitoes? You know the where's Coxet just now? It's a thing that does look like this. Is be a kind of cool thing like this, and it's light one end on fire. Right, that's pretty popular. I should really ask that, right? Everybody should know about that, right? You all ever heard about the brand called Fish Brand? That's the name of the brand. And when you buy the Coxet, it does have a fish on it. For some reason, the mascot of that brand is a fish. Nobody ever, I never really put two and two together, you know? Like, why would you put a fish on a packet of Coxet? What does fish have to do with Coxet? Right? Okay, but this is the most popular brand of Coxet. I'm not lying to you. The older folks in class will know about this brand, right? So it turns out that there's a certain type of fish that eats mosquitoes. It's known for eating mosquito larvae. So if you have a pond that has a lot of mosquitoes, and well, not in Trinidad, we don't use this particular fish in Trinidad, right? But I think it's very popular in China and those places, right? If you know you have a pond or a river with a whole set of mosquitoes and they're laying their eggs and larvae starts to appear, apparently there's a fish, a special fish that can go around and it eats the larva. That is what the fish is known for eating. So a lot of people introduce that fish into the streams and rivers. So that is what I call a biological method of control. So a biological method of control is when you use another animal to kill the other animal. So in this case here, they're using a special fish that feeds on mosquito larvae. Pretty smart, right? So, and that is why their mascot is the fish. It is that particular fish. Because the cockset is also driving away the mosquitoes, like how that fish gets rid of the mosquitoes. So that is why they call it fish brand cockset. Right? I only realized that a couple years ago. Like I put two and two together. Right? So that's a biological method of control. Just another popular example of biological control. Do you all know that in Trinidad it never used to really have a mongoose? How much of you all have seen a mongoose in Trinidad? Right? It usually runs behind your house, so it's been your bushes and whatnot, right? Right. Let me give you the story of the mongoose. I don't believe the mongoose is natural to Trinidad. So like about 200 years ago, you couldn't find a mongoose in Trinidad, as far as I can tell, right? So when a long time ago, Trinidad was known for growing what? Sugarcane, right? So about 40 or over 100 years, Trinidad had sugarcane. So how would you have this sugarcane? The workers would have to go, right, into the sugarcane fields and cut down the sugarcane with their cutlass. But inside the sugarcane fields, there will be plenty snakes. So this is true, and a lot of workers would die from snake bites. So the snakes were becoming a problem. So the plantation owners had to come up with an idea, like we can't have the workers dying from snake bites. So guess what they did? They imported a lot of mongoose and then let the mongoose loose into the sugarcane fields. And what are mongoose known for? Killing snakes. So that's a biological method of controlling. Well, in this case here, the mongoose not controlling the mosquitoes, but it's controlling what? The snakes. Right? And that's how the mongoose is all over Trinidad now, because they introduced it about 100 and something years ago, and they reproduced and whatnot and whatnot and whatnot. Right, so just to summarize, biological control is when you use another animal to kill off or control another animal. And the last one on the list is the high-tech one, gene manipulation, right? So gene manipulation is when you start to play around with DNA and you start to mess with the DNA of another animal. And there are many types of gene manipulation. I'll give you one example. I'll give you two. So I'll give you one and then I'll go back to biological, right? An example of gene manipulation is that they manipulate the DNA of certain insects, like a mosquito. They will get some mosquitoes and alter their DNA so they're unable to reproduce. So these mosquitoes can't have, well, children mosquitoes, right? So, and what they do is they release all of those mosquitoes into the environment. So now, what will happen is that reproduction cannot take place. And eventually what? The insects start to die out because they cannot what? Reproduce. Oh, and another example of biological control. This one is pretty grim, right? For those who have an imagination. Remember, biological control is most of the times when you use an animal to kill off another animal. But sometimes they will take an insect and make it sick. They will inject it with a virus, a deadly virus. Now, the virus doesn't kick in immediately, but what will happen when you release that insect into the population, into the environment, that insect is going to spread the virus or disease to the other insects. So what's going to happen now? All the insects that particular insect comes into contact with gets the virus and they what? Eventually die. So in another example of biological control is when instead of using another animal to kill another animal, you use a intentional virus to kill out the other the other animals. Okay? Everyone okay with that? This is a pretty popular example thing in the exam. They like to ask, how can you control vectors? And they might ask you to state 3 out of the 5 reasons. And then they might what? Ask you to do what? Describe a couple of them. All right, so pretty straightforward. Remember, you don't have to make notes today, right? Let's move on to the other slide, right? So remember, the first letter, I already called it. The next letter I want you all to take down is the letter K. Write it down. Letter K as in kangaroo. Right? I'm not calling back the first letter, guys. Don't try to trick me into calling back the first letter, right? Right. Okay, guys. Here's what this is like a kind of summary of what I just said, right? So give this a read and let me know if there's anything that you need explain on this slide. But take your time, read it through, and process it there. Someone asked, I guess the majority of people may not have heard of something called what pronounce it, Lyme disease, right? How to say this? It's spread by a tick. I remember how ticks just live on animals, like they just like suck the blood of animals, like dogs and whatnot, and cats. Anything that has fur, ticks usually go on it, especially rats and whatnot. So it's a disease that's spread by ticks, and when it bites you and whatnot, you can get pretty serious symptoms like extreme fever, headaches, and whatnot. Right? Don't worry, the examiner isn't going to ask you to explain what that disease is. You just be able to quote some diseases for. Right. So personal hygiene. Now we obviously know diseases, um, and being clean. Hygiene is what? Being what? Clean, right? Right. Just guys, I did not call a third letter as yet. Please pay attention, right? When I'm calling a letter, I will make it very, 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 very clear. All right. Great. So we all know hygiene, right? We all know hygiene and diseases are very, very closely related. Very closely related. We all know if you keep yourself dirty and your environment dirty, right? It's going to attract what? Unwanted pests, right? It's going to attract vectors, okay? So I think that should be clear. Now, a lot of time in the exam, they like to ask you questions about hygiene. Now, I know lot of these things here are going to be common sense because I can make the assumption that in primary school, didn't they teach you a lot about being hygienic? Like what to do with your environment, how to take care of yourself, simple things like what, brush your teeth. And so this part here is pretty common sense, but I still want to talk about it just in case, because primary school is a long time ago, right? But anyway, let me see what's going on with old Jibby here. So Jimmy says, bathing is a conspiracy theory, Lord, created by the government to make us buy soap. All right, Jimmy, don't know what's going on with him. If I personally just limit my sweating, I don't know how he does that, and haven't needed a bath in 20 years. All right, so clearly, I think we figured out why Jimmy doesn't have much friends, right? So anyway, yeah, for 20 years, right? That's crazy. Right. There's a piece of history, right? Or you all know the ever heard about the pirate called Blackbeard? He's a real pirate, well, Blackbeard the pirate. It has been a lot of movies, but that's a real pirate, right? So apparently from being a pirate, even though he's been at sea, he has water all around him. Apparently, he never took a bath for pretty much his adult life. So, like, you're talking about 20 years and thing. Like, literally, he never took a bath. All right. So, I don't know how he lived. But anyway, so what these are some ways to take care of yourself, and of course reasons for being what? Hygienic. Okay, give this a read. I don't think any of this will be new to you guys, but still give it a read because it comes in the exam. It's easy marks. To the next slide. All right. Sterilization. I'm gonna use two words, right? Sterilize and disinfect, right? Sterilize and disinfect. How much of you all think that those two things are the same thing? We all know when you sterilize something or you disinfect something, we know it has to do with something making it cleaner. Like a needle, when you go to the doctor, they just have to sterilize the needle. So we know sterilization has to do something with cleaning, as in removing all the germs, okay? And disinfect. I'm sure everyone here has a disinfectant home, right? Like Oh God, you know the disinfectant your parents is buy is be colorful and like purpley or reddish, and you just put it on a cloth and clean down the counters and like Lysol. Correct, yeah. Somebody said it. It have black disinfectant and whatnot, right? So here's the thing. Sterilization and this it's slightly different, right? But both of them have to do with cleaning. So let's go with the first one, right? There's just a little revision. Sterilization refers to the process of eliminating microorganisms, right? So a microorganism is things like germs, bacteria. You can think of it as bad things, right? Things that will make you sick. I have it here, including bacteria, viruses, fungi, spores from an object surface, right? So that's sterilization, right? And usually you just hear the word sterilization when it comes to needles, and believe it or not, food. A lot of the food that you buy from supermarkets have been sterilized, okay? Now, sterilize, let's just keep it simple. I don't want to keep saying that sterilization is the removal of bacteria, viruses, fungi, and spores. I'm just going to use bacteria for my example. So I'll say the word bacteria, and that represents all the microorganisms. Before we can understand sterilization, we need to understand what makes bacteria live. And we did this a few weeks ago. For bacteria to live, it needs three things: oxygen, water, and a good temperature. Bacteria tends to live between 5 to 60 degrees Celsius. It's almost the same thing as you, a human being. For you to stay alive, you need three things, right? You need oxygen. Well, you need a little more than three, but you at least need oxygen. If I take away your oxygen, you're dead. If I take away your water, all your water, you die. And if I make the place too hot or too cold, you what? Die. Okay, so keep that in the back of your head. Now, I want everyone to try to come up with some very common sense reasons why we would need to sterilize food. I will give you the most obvious one, and I don't want anyone calling back the most obvious one. The reason we sterilize food is to remove the harmful bacteria. Because remember, harmful bacteria, let me say you buy milk and it has harmful bacteria in it and you drink it, you are going to get what? Sick, or you could die. So one reason for sterilizing food is to remove the harmful bacteria so you don't get sick. I'm looking for another reason. What's another possible reason for sterilizing food? Navid, correct. The answer I'm looking for is to extend the shelf life. What do I mean by extending the shelf life? I don't want the food to spoil. Remember when you're buying food in the supermarket, right? And it have an expiry date? Which one do you think will last longer in the supermarket? If I do not sterilize the food first and put it on the shelf, or do you think the one that has been sterilized and all the bacteria removed, do you think that one will last longer? And the answer is what? The one that has been sterilized will last longer on the shelf. It has a longer shelf life. The expiry date will be longer, which means as a company, that's a better product, right? Because you know what happens in groceries when the product spoils on the shelf, they have to throw away all of that and they make what? A loss. All right, so just to summarize, the main reason for removing bacteria, one is to definitely prevent diseases. And the second reason, it always extends the shelf life. So let's move on, right? So let's talk about the difference between sterilization and disinfestation, right? I used to mix this up. Obviously, when I was younger, I didn't really understand the difference, right? But, it's a good thing I did this subject. So here's the thing, and they love to ask this question. It usually comes as almost the last question in the HSB exam. And of course, it comes, I think, in question 3 in the integrated science. Sterilization refers to the complete elimination or destruction of all forms of microorganisms, including spores. So sterilization is powerful. Once it living, it killing it and taking no prisoners, nobody surviving after sterilization, right? Sterilization don't even care if you use good bacteria or bad bacteria. And a lot of people don't know that. Not all bacteria is bad, right? Inside you right now, it have bacteria. Right now in your intestines, right now, it have plenty, trillions of bacteria. But believe it or not, some of that bacteria is actually doing good things inside of your stomach. All food, no matter how much, like if you ate food this morning, it have bacteria on it. The question is, does it have bad bacteria or bacteria that just doesn't harm you? Okay, right? So at the end of the day, sterilization doesn't care. He killing all bacteria, good or bad. Don't care, right? So this infection, right, aims to kill or inactivate some microorganisms. It doesn't actually what? Kill all of them. You see, disinfectant might just target certain types of bacteria. It doesn't kill all. It's very selective in who it killing. So different companies will develop different types of disinfectants, and those certain type of disinfectants will only kill certain types of bacteria. And disinfecting doesn't mean what? It kills all. It could kill them or inactivate them. Inactivate them means that it damages the bacteria in such a way, probably the bacteria can't reproduce now, or the bacteria living is just not able to what? Move, or it damages. It's like if you inactivate somebody, right? Like it's the only thing I can think about right now. Sorry for the gruesome explanation, right? But instead of killing someone, right, you could inactivate them. Probably you could break their legs, right? So they can't function properly. That's different from, well, killing someone, right? Like I apologize for the gruesome example, but that's almost the same thing here in terms of the bacteria. You don't actually kill them. You could, but you could also have the option of inactivating them. Right, so that's a clear difference between sterilization and disinfectation. Give the table a read. The table goes into more details now of the difference between the two. Any questions? Ask me. I'll gladly answer. Figure it out. This word is supposed to be clean, not clear, right? Use the clean surfaces, right? So some people realize I made a little grammatical error there. All right, so we're going to talk about different methods of sterilization. And you have to be able to describe all of them in the exam. I'm sorry. I know this slide looks like a lot to remember, but like anything, right? You're going to have to revise and practice writing it back over and over. So let me just read back the top there in yellow. Sterilization, that's the one that kills everything. He doesn't care. Good, bad, killing it, right? Sterilization refers to the process of eliminating all microorganisms, including bacteria, fungi, spores, blah, blah, blah. We know that. So sterilization is very important, definitely for medical equipment, because if your doctor is giving you an injection, you notice every time they're giving you an injection, the syringe is coming in a plastic sealed bag. Well, I hope your doctor uses that, right? That is because when they bought it from the factory will have sterilized it. Sometimes they they put very powerful chemicals on it. Sometimes they use radiation. Yes, radiation. They pass it through a machine that shoots radiation on it, and it kills every single living organism on the syringe, and then they bag it up. They put it in a little plastic wrap. Okay, so and it's also very important in foods. Okay, if I know I buy in milk, I want to make sure the milk I buy in the grocery doesn't have any bacteria or any living organisms in it. I want pure, healthy milk. How much of you all have seen this UHT milk? I'm sure when you go in the grocery and you see all the different brands of milk, it have Nestle, it have Moo, it have oh god, what are some other brands of milk? I can't remember. It's only Moo and Nestle I usually buy. You'll never see UHT written on milk, like this milk is UHT and it is written big and bold, like it's something so good for the milk, right? And I know a lot of people out there don't know what UHT means, right? Here's the thing. UHT actually stands for something called ultra high temperatures. We all know very high temperatures can kill organisms, right? Most bacteria cannot survive very high temperatures, right? So what they usually do with the milk, right? Before it goes into the packaging and goes to your grocery, they heat it up very, very, very high, obviously. Okay. And these are the temperatures they heat it up for. They usually heat it up to about 150 degrees Celsius, but they only do it for a few seconds. And of course, this will kill all the microorganisms present, right? So to me, UHT milk is something good because I know once it write UHT on the packet, that's the method they use to kill the organisms. Another one, a slightly different one, is something called pasteurization. This is also written on so many milk products. And of course, a lot of people don't know what it actually means. They just see a fancy word and they pick it up and throw it in their trolley, but they don't know what it means. It involves heating in liquid, not as high as UHT, but to about 63 to 72 degrees Celsius for 30 minutes, or this temperature for 15 seconds, and they cool it. So this one is a little more subtle than ultra high temperature. So some companies will use UHT method. Some of them will use the pasteurization method. Remember, bacteria cannot really survive above 60 degrees Celsius, right? So 63 is good enough to kill off the bacteria. It's just that some companies did just decide to go to a much higher temperature to be super, super, super safe, right? Autoclaving, right? It uses steam and high pressure to kill organisms. Tell me something. Let's pretend you are a bacteria. If I put you in steam, is steam hot? Yes. You ever feel steam when you're boiling water and you put your hand over the pot and feel that steam? And that is be real, real hot, right? And of course, pressure. If I increase the pressure, the air pressure around you, it will crush you. So some companies just use steam and high pressure. They will run the food through that. They call that autoclaving, right? Well, boiling is pretty obvious, right? Whenever you have contaminated water home, and it is advised to boil the water to kill off all the germs and bacteria. So you can also use boiling and canning. Now, a lot of people don't understand how canning works, right? When you buy canned tuna or canned sardines and whatnot, right? How does that preserve the food? Because I'm telling you, if you have a canned tuna and that's sitting in your cupboard for 10 years, 10 years later, that tuna's still good enough. You could keep that for years, 20 years, 30 years, 40 years. And that tuna, I guarantee you, will still be good, right? So how does canning work, right? This method involves placing food, obviously, in a can. No big surprise there. Sealing the can. Why do they seal the can? Remember, They seal the can, first of all, to prevent other bacteria from coming in, and also sealing the can prevents air from getting into the can. Remember, bacteria need oxygen to live. So if you seal the can, won't it prevent oxygen from getting into the can? So the bacteria cannot survive, okay? So you seal it off. And then after you seal it, you heat up that can and increase the pressure. Just in case inside the can, some bacteria survived, you heat up that whole can and kill all the bacteria inside there. And then you let it cool down, and then you send it to the grocery. Right? So these are 5 methods of sterilization, of sterilizing food or anything around you. Right? Any questions on this particular one? Right? I think I went through it in real detail here. So, right. Let's get ready to move on. All right. So, how about this term now? Antiseptics versus disinfectants. Well, there's a slight difference between the two. And of course, a lot of people might think it's the same thing, but if you use both of them in the wrong way, it could do some serious damage. Yeah, antiseptics, right? And both of them deal with killing bacteria. But antiseptics are more gentle. You just use it on human skin. Disinfectants are used on inanimate objects like a desk, a kitchen counter. How much of you all, and be honest, have made the mistake that you have a cut, and instead of putting the correct thing, which is an antiseptic, which is made for human skin and tissue, it can't be too strong, decided to use disinfectant. Like you had somebody in your family say, hey, just put the disinfectant on your skin now, you'll kill out all the germs. How much, be honest? Right? No, never. Serious. I guess that this used to happen when I was growing up by mistake. Right? Disinfectant will damage your skin. Don't get me wrong, it will kill the bacteria, but it will damage your skin. It will blister it up. It might actually make it bleed more because it blister up your skin so much. So the moral of the story is this. Please don't use disinfectants on human tissue. Antiseptics are more gentle and they are made for human tissue. All right. So you can give it a read here, but everything I just said is in writing there. But, I'd like you to read it just in case. All right. Right, so here are some words. I call this the great A's, right? It's 4 A words, right? You'll see it below there, right? It have a whole set of words, right? But 6 here, we have some repeats. It's a whole set of A words that resemble, that sound the same, or people generally think all of them is the same. And of course, it's not true. So things like antibiotics, are antigen, are antibody, and are antitoxin. All of those things are different things. So let's just quickly read and describe the difference between all of these things, because you're going to hear all of these words repeating for the rest of class. So I think the easiest one to relate to is the antibiotics. How much people here have gotten sick and your doctor recommended antibiotics? Right. I've been on antibiotics for on and off for I know why. I get sick really, really, really quickly. So antibiotics kill microorganisms. So you take the tablet, it goes into your stomach, and then it starts to kill bacteria in your body. Quick question. Does antibiotics kill the bad bacteria or does it kill all bacteria? Quick question. In your body, when you take it, does it kill the bacteria that's giving you problems? That specific bacteria? Or does it go on a rampage and just kills any bacteria it sees? Which one does antibiotics do? I honestly used to think antibiotics used to kill certain type of bacteria, but that's not true. Antibiotics is going on rampage. He don't care. He does just kill all. Good and bad, you're gone. Right? So that tablet you're taking for antibiotics, it's like it's like this. It's like you have a murderer who's on the loose, and the murderer is in the crowd, but you don't know who the murderer is, right? So instead of looking for the murderer, you just say, hey, what? I'll just kill everybody. Right? That is how bacterias work, right? It's crazy, right? But there's a problem with antibiotics. How much of you all have heard you should not take too much antibiotics because your body does get immune to it? Like me, I've been taking antibiotics since I small. I am pretty sure by now antibiotics don't work on me anymore. How much of you have heard that? That antibiotics, after a while, it stops working on you. And that is why they just tell you, hey, only take antibiotics if it absolutely, absolutely necessary, right? And I'm going to explain why that happens. You see, the bacteria will learn. You see, when the antibiotics kill, like let me say it have, I'm going to draw some bacteria here, right? So let these dots, let me say it have 3 bacteria. I'll put 4, right? And then you take the antibiotic pill. Now, for those who have taken antibiotic pills, how much of you all have taken the red and black pill? You just can't miss it. Well, it's so popular. When you go to buy it, it'll be red and black. But this is supposed to be the pill, the antibiotic pill. That is cost like $100 or something like that, right? For a pack. It's real expensive. Right. So the antibiotics, you're supposed to take it for about 7 to 14 days. Now, let me say the doctor say, hey, take it for 14 days, right? So over the 14 days, right, the antibiotic starts to kill the bacteria. So let me say we on day 10, right? 10 days have passed. And by day 10, the antibiotics kill 1, 2, 3. Now we only have 1 bacteria left, right? So because there's only 1 bacteria in your body, you're feeling good. So you know what most people is do? They just say, all right, the doctor tell me to take it for 14 days. 10 days passed. I feeling good. And what people is do? They just stop taking the balm and they just stop taking the antibiotics. But that is a problem. You know why that is a problem? Because this bacteria, I'll call him Jimmy. Jimmy just saw the antibiotics. So he knows about the antibiotics. So what he will do, he will develop, he just lived and he develops an immunity to it. He figure out a way to do what? He figure out how to survive the bacteria. So Jimmy knows the bacteria's secret now because he's allowed to live. When Jimmy reproduces, do you think Jimmy's children will have the same immunity? Do you think he will pass down that immunity to his children? What do you think? Because Jimmy is allowed to live and he knows the secret of the antibiotics. And the answer to that question is yes. So when Jimmy reproduces, all of Jimmy's children are now immune to the antibiotic. So the next time you take the antibiotic, you think that antibiotic is going to work? No, because all the bacteria now have reproduced in the person's body, well, your body, and all of them have what? An immunity to it now. So that is why your doctor, if your doctor tell you to use it for 14 days, use it for 14 days. Because your job is to make sure you kill off all the bacteria. So there are no survivors. So nobody learns what? The secret of the bacteria. Right? And this is a mistake I made in my life, right? I never listened to my doctor. And when I started to feel good, I stopped taking the antibiotics. And that is why I feel now that antibiotics don't work on me anymore. Because all the bacteria in my body have learned, I left some to survive. And they all know what the secret of the antibiotics now. Okay? I don't know who Jimmy's wife is. All right. Now, just like how antibiotics kill bacteria, antifungal kills fungus. No big secret there. A fungus and a bacteria is two different types of organisms. I just don't want to get into it right now. Just know a bacteria is different from a fungus. How much of y'all have used antifungal on your foot? You know, sometimes when you wear shoes and it gets sweaty and, oh God, you wear it whole day and then a week passes and, you know, your foot starts to itch, like real itch. That is because your foot is developing a fungus. And to get rid of it, you need to what? Apply antifungal cream. Right. So we know what an antibiotic is. I have it here. An antigen, right? Is an antigen, right, a good thing or a bad thing? An antigen. An antigen. Is that a good thing or a bad thing? Some people will say it's a good, well, let me describe it. It's a good and a bad thing if you depends on how you look at it. Let we say that you have a bad bacteria in your body. So this is a bacteria, a germ. A germ has just entered your body. I'll put a little that's the bad bacteria. He has come to make you sick. So he just entered your body. Who is supposed to fight off that bacteria in your body? I did it last week, the week before, and the week before that. Who is supposed to fight off that bacteria? I'll give you a hint. It starts with the letter W, right? The white blood cells. Right. So the white blood cells is supposed to is supposed to fight that bacteria for you, right? But I drawing little googly eyes and thing here. Obviously, a white blood cell doesn't have eyes. So it cannot see the bacteria. So I just remove the eyes there, right? Right. So how does the white blood cells know of the bacteria? And here's the other thing. How does the white blood cells know what kind of bacteria? Because it has thousands and thousands, probably millions of different types of bacteria. For the white blood cell to fight the bacteria, he has to first figure out, hey, what kind of bacteria is that? You see, bacteria have certain things on it called antigens, right? Antigens. That's this. Different bacteria will have different types of antigens, right? There are thousands and thousands and thousands of different types of antigens. So how does an antigen is almost like a fingerprint to help you identify somebody. So the white blood cells will go up to the bacteria and it will touch or come in contact with the antigens. And by touching the antigens and realizing the shape of the antigens and everything, it will say, aha, I know what kind of bacteria I am about to fight. So that is what an antigen is, right? The antigen basically stimulates the white blood cells to figure out, hey, what kind of bacteria I have to fight. So, and whenever you call that an immune response is when the white blood cells getting ready for battle, right? It knows it has somebody to fight. So remember, there are two types of white blood cells. One that will just simply eat the bacteria, but then it have the sophisticated one. Well, what's the name of the sophisticated white blood cells? The one that just doesn't eat the bacteria. Like he goes up to the bacteria, investigates the antigens, and tries to reason out what type of bacteria he is fighting. One starts with P and one starts with L. I'm looking for the smart white blood cell, the one who's intelligent, sophisticated. Go back in your notes, which one is the sophisticated white blood cell? Because that's the one I'm talking about right now. No, it starts with the letter L, Jordan. L. Guys, it starts with the letter L. That's the one. L, please send something starting with the letter L. It's your lymphocytes. That's the type of white blood cells. The other type of white blood cell is the phagocytes. That's a caveman one that just eats the bacteria. I'm talking about lymphocytes. So here's what now. When the lymphocyte goes up to the bacteria and he investigates the antigens, remember the antigens are on the bacteria. Once the white blood cells figures out the type of bacteria, it will devise something to kill it. The white blood cells will start to make something in it. I'm going to use little diamonds here, right? And it will make these diamond things and send it out. And these diamond things will attack this particular bacteria. So the thing that the white blood cell just made is something that will kill that specific bacteria. And you call that what? An antibody. So white blood cells make specific antibodies to kill that specific bacteria. But it can't make the antibody until it figures out what kind of bacteria it's dealing with, right? And there's another thing. Sometimes bacteria produces toxins, right? An antitoxin is something that will fight against the toxin. So if the bacteria releases a specific type of poison into your blood, like it makes a poison, you call that poison a toxin. Your white blood cells can also make what? Antitoxins. Right? So everybody think if I use these words later on in class, you think you'll have a decent idea of it because I'm going to be using it over and over, right? So know the difference between those A words, the great A's. Right. All right. So the next thing I'm going to describe here is the types of immunity. To keep it simple, your body's immunity system is the one, obviously, that fights off infections, which is basically a white blood cells. So what I'm going to be discussing for the next 10 minutes is how the different methods your body can get white blood cells. White blood cells are good, right? So how does your body make the white blood cells? Or how does the white blood cells get into your body? Well, there are two categories, right? Two categories. Innate immunity and adaptive immunity. Let's clear up the two main categories. Innate immunity is the first line of defense against pathogens. Don't let the word pathogens get to you. A pathogen is just a fancy word for germ. And it is present from birth, right? It's a non-specific type of immunity that provides immediate protection against a wide range of pathogens. Let me just simplify that for you. When a baby is now born, the baby now come into this world. You know what the bacteria will do? Remember, it's in a new world. Bacteria from the environment are just going to rush towards that baby and try to make the baby sick. A baby is born with some form of protection, right? It is born with an immune system. Now, the immune system is not the best immune system in the world. Remember, the baby now born. So it's a kind of basic immune system it's born with. And that will fight off some of the bacteria. It's just enough to keep it alive so it can grow up a little bit, right? So innate immunity is the immunity that a child is born with, given to it at birth. Adaptive immunity. This happens after the baby is born. You see, after the baby is born and the baby is growing up, it comes into contact with other germs. And over time, while it is growing up, it will improve its immunity system. Makes sense, right? You're born with a basic immune system, but you can't live with that for the rest of your life. You need to improve yourself. So over time, the baby will what? Improve or make adjustments or make modifications to its immune system so that it gets better and better and better, right? So give it a read. The two main categories of immunity, one at birth and one that continues to get better as the child grows older. All right, so this is something I just discussed, but let me use my real cool diagrams here, right? Here we have the lymphocyte. That's the white blood cell here. He's white and whatnot here, right? So this is how it kind of looks. And then you have the pathogen. Remember, the pathogen is the germ. I just want to put the word germ because more people are accustomed with that word, but the real word is pathogen. Remember, the pathogen will have what? Antigens on it. These are like fingerprints. The antigens allows you to figure out what kind of pathogen or germ it is. So what will happen? Look at the animation here. The pathogen has just invaded the body. The white blood cells needs to figure out, hey, what kind of pathogen am I dealing with? So it disappears, it goes closer. You all notice that the lymphocyte is making contact with the pathogen and it's investigating its antigens. So the lymphocyte is going, okay, I know what kind of pathogen I am dealing with. So what the lymphocyte will do now, it creates antibodies. So inside now, the white blood cell, it starts to create these things that will kill that particular pathogen. And then it releases it into the environment. And these antibodies will begin to attack the pathogen and kill it. But it's very important to remember that these antibodies that were now developed will only kill that particular pathogen. So every time the lymphocyte comes in contact with a new type of germ, it has to reinvestigate, make a brand new type of antigen, and then throw it in. Now, here's the thing. I'm going to ask you all a question. You all notice that when you get sick from something, the first time you just get real sick. But the second time that same disease comes around, you don't get sick again, or you just get only a little bit sick. Anybody ever realize that? How much of you all realize that? That the first time you get sick, you just get sick real bad. But if the same disease comes around, you don't usually get sick again. Anybody ever realize why? Well, here's the thing, right? Remember, let's say you recover, right? So the lymphocyte kills this pathogen, right? Whenever this pathogen, this same exact pathogen comes back to invade the body. So the pathogen said, all right, we failed the first time, guys. Let's re-attack. White blood cells just remember. So you see the antibodies that it have there? It just remember it. It is already have it stored inside of him. The white blood cell doesn't need to go and reinvestigate the pathogen. He remembers the pathogen. So as soon as this pathogen comes up, bam, he just releases the antigen one time. He don't even have to bother to investigate. So the pathogens don't have a chance the second time around. The white blood cell is ready for him, right? So, and that's worth knowing, that white blood cells always remember how to attack somebody who already attacked them in the past. It remembers. Okay? Your body does get accustomed. I guess that is the word. Your body does get accustomed, right? Right. And this here is the phagocyte. This is a different type of white blood cell. The phagocyte doesn't investigate the pathogen, he just eats him. Right? He's the caveman, right? So, but you all know that already. Right? So that's my depiction or my imagination of the phagocyte just eating the pathogen. He doesn't cater. All right. Right, so let's see what's going on with Jibby here. Jibby the Great, Lord of Knowledge, not even knowledge, knowledge land, has prepared an immunity, a test on your immunity. All right, so everything is spelled wrong there. Sorry, I gave away the answer. Sorry, so I gave away the answer for the first one. What does your body create to defeat pathogens? The answer is what? Antibodies. What's the answer to the second question? If your body creates its own antibodies, what type of immunity is that called? If your body creates its own antibodies, like right now, you're not in contact with anything. Let's say your body right now is developing, it's improving its immunity system. What do you call that type of immunity? Sorry, you all might know the answer to this one because I'm about to do it. It's called active, right? Oh, sorry, I haven't done this part as yet. When your body creates its own immunity with no help from anybody else, it's called active. What is the opposite of active immunity, meaning that your body isn't doing it on its own? You call it passive. So now we're going to investigate what is active and what is passive immunity, the difference between the two of them, right? Before I move to the next slide, the next letter is G. Write it down for me, please. I'm writing it on the screen here. It's the letter G. It doesn't matter if it's capital or common G. It doesn't matter, capital or common G. But the next letter is G. So we have 4 letters now, right? All right, let's go. And the next one, what is a vaccine? How much of y'all didn't know this? When you go to take a vaccine or you get a vaccination, do you know they're injecting you with the actual virus? Like, for example, everyone here would have gotten what type of vaccine? Now, just help me out here. Tetanus. Everyone here got the tetanus vaccine? Or H1N1? Right. Do you all know that when you let me say it's a H1N1 vaccine. So H1N1 is a disease, right? Do you know when they inject you, they inject any disease inside of you, but just a weaker version of it? So a vaccine is actually the infection that you're supposed to be preventing. But I'll explain how that works. So, but it actually makes sense, right? If I inject you with the virus, or a very mild form of the virus, won't your body start to develop antibodies to counteract that virus? So by injecting you with the virus, I force your body to get strong to it. Okay? All right. So let's have a look here. So, and this is a real important piece here, right? Types of immunity. Now, we have 4 categories here. You need to memorize this here. We know active is the one that where your body and your body alone develops its immune system. It doesn't get anybody help. It doesn't get any outside help. But there are 2 types of active: natural and artificial. Natural is when you let your body be exposed to the virus and you're ready to do anything about it. You ever notice that when some people get sick? I had a friend like this. When he gets sick, he don't take any medication, you know. He just let his body fight off the infection naturally. And he did that because he wanted his body to become strong. You see, if you, I don't really recommend it, right? Your doctor will have to make the choice whether that's a good choice for you. And that's what he did. By letting his body fight off the infection without any tablets or any help, he ensured that his body developed the antibodies properly. So that's natural. Or you can take a vaccine. So somebody will inject the virus into your body, and your body now will take up the challenge. All right, I have a virus to defeat. I'm going to practice developing antibodies to defeat that virus. So your body is handling it. It's developing its own antibodies. But one is natural and the other one is artificial, because a vaccine is something man-made, right? It's made in a lab. So it stimulates your body to make what? Antibodies. The opposite of active is passive. Passive is when you don't make those antibodies. Remember, your white blood cells is supposed to make the antibodies. But passive is when your white blood cells don't make the antibodies. And one way of that is when some children are born. Well, not some, when children are born, remember the mother will have antibodies. Your mother living for how long? She's going to develop her own set of antibodies. So when you are born, she passes it down to you. So it's like you get some free antibodies when you're now born. But you didn't make those antibodies from your white blood cells. It was your mom who made those antibodies with her white blood cells. And she gave the antibodies to you as a gift. Okay? Or sometimes you can just make the antibodies in a lab, right? You grow the scientists have figured out how to grow antibodies in a lab. And then they use a syringe and take out the antibodies and they inject it into you. In either of these 2 cases, your white blood cells were not involved. Your white blood cells didn't make any of those antibodies. It was made either by your mom or it was made in a lab. You call that passive. Give everything a read there, right? Let me know when you finish. I'm giving you a minute. Read it through properly. All right. So the next part of this syllabus here deals with drug use. Right now, this part here is going to be easy. I think we all know by now drugs is bad. Off the top of your head, I think everyone could call different types of drugs out there, like cocaine. It have LSD. It have heroin. Alcohol. Believe it or not, alcohol is a drug. And I think we know by now, right? Right? We know by now drugs are bad, right? Right? And of course, drugs are addictive, right? They are very, very addictive, right? So That's all. But you had to be able to use some fancy words, I guess, in the exam, right? Drugs can become addictive. The person could be dependent two ways on it, physically or psychologically, right? So psychologically is the one where you're thinking about doing the drugs whole day. Like you're probably in school or you're probably at work and whole day you just thinking about alcohol or you're thinking about cocaine because it has totally taken over you. That's all you care about and can think about. And physically means, I don't know if you all have ever seen someone, if someone isn't doing drugs, like they're doing drugs and they didn't get their drugs for the day. You ever see them like shaking? They just be shaking and the head and thing is be twitching and whatnot. It's because the body can't physically do without it now. Your nerves and your brain need that drugs to stabilize your nerves. So that's physical dependence, right? It's a terrible, terrible thing to watch in someone, okay? So, but it have different types of drugs. Now, when people hear the word drugs, right, they just automatically think what? Cocaine, right? Or heroin, or it have new ones out there. I can't remember any new ones out there, right? But and drugs can also be prescription drugs. And when you go to the doctor, right? And if you're real sick and he just prescribe legal drugs that have legal drugs out there, right? But sometimes people become dependent on legal drugs, like sedatives. You ever hear about something called calms? Anybody here, the parents is use calms? I know the younger children won't be using calms, but calms is something you could buy in a pharmacy. It calms your nerves. It like if you're an anxious person and you can't sleep and thing, right? For whatever reason, you might be having family problems and whatnot and things. So you buy calms, right? It makes you calm. It's a sedative, right? But people become hooked on it. All right. Painkillers. I know someone who's addicted to painkillers. They will just take painkillers whole day. The slightest pain they have, they're taking it because the painkillers makes them feel a certain way. It makes them feel a little high, I guess. Okay, so they're no longer killing pain. They just get addictive to the side effects of that particular legal drug. So they start to abuse the drug, the legal drug now. And then this one here, I discussed this one here already, antibiotics. You should not be taking antibiotics for every little thing. And we know why, because after a while, your body is going to what? Become immune to antibiotics, and the antibiotics not going to have any effect on your body, right? So these are like prescription drugs, right? These are prescription drugs that people can get hooked up on, right? So let's move on. I know we're coming to the end of class. I just want to make sure I finish this topic today. I don't want to come back on this topic. I want to start something new. And these are some examples of non-prescription drugs. Most of these are illegal. The only legal one here, I think, well, right now, totally legal is alcohol. Give these a read. I'm guessing that you all probably know most of these already. This is like common knowledge now. I know in school they just bring people in to talk to you all about drugs and thing and why bad and what it is do and whatnot. Right. Right. So we know by now drugs can have what? As it can destroy not only people, it can destroy whole families and it can destroy a community and it could what? Destroy a whole country, right? I know you might think that destroying or affecting a whole country is far-fetched, but remember, drugs lead to what? Crime, right? And also drugs lead to many health problems. So when people do drugs, they get really, really sick. And guess where they just go? To the hospitals. And they just take up space in the hospitals, right? So when you go to the hospital, they mightn't have a bed or a doctor might not be available because they're taking care of someone who has been doing drugs. So these are some, I guess, a description of how drugs affects individuals, family, and community, right? I don't know if you all know from first-hand experience, have you ever seen drugs destroy a family? I have, right? Seen one individual started to do drugs in the whole family, and because that one person was doing drugs, his whole family fell apart, like whole family, just because of him, right? Right. So you can give it a read. Shouldn't be too hard to understand, right? We finished. And yeah, that's the last slide, guys. Look at